In this video, we are going to be talking about the distributive property and the use of the greatest common factor. This corresponds to your lesson 2.1b. Let's think about a real-life situation that allows us to use the greatest common factor. If we had 10 groups of 4 girls and 5 boys in a group, how many children do we have in total? Well, if I rewrite what's written here, 10 groups of 4 girls is like saying I have 10 times 4. And I also have 10 groups of 5 boys. That would give me 10 groups times 5 boys. Well, in total, 10 groups of 4 girls is 40 students. And 10 groups of 5 boys would be 50 students. So altogether, I would have 40 plus 50 students. So I would have 90 in total. If you remember from our discussion about greatest common factor, I could reword this question by saying I have 40 girls and 5 boys. What is the greatest number of groupings I could make of the same amount of girls and boys? And when you look at 40 and 50, the greatest common factor would be 10. 10 is my GCF. And if I have 40 girls, each being in 10 groups, I know I'd have 4 per group. And 50 boys, having the greatest groupings of 10, would mean I'd have 5 in each group. So this is starting to look a little similar to what we have done in class. And when we have rewritten it like this, 10 groups of 4 plus 10 groups of 5, we're actually using something called the distributive property, which we're going to jump into right now. So let's look at this question one more time. If we had 10 groups of 4 girls and 5 boys in a group, how many children would we have? And we talked about how we would have 10 times 4 plus 10 times 5. And another way of writing that is by saying 10 times 4 plus 5, because there would be 4 girls, plus 5 boys in each group right here. And that makes 9 in a group. And then 9 in a group times 10 groups is 90 students. So I could write this situation out by saying 10 times 4 plus 10 times 5, or I could say it's 10 times 4 plus 5. So just like we talked about in class, the distributive property is when you multiply the sum of two numbers by another number. You can actually multiply each addend in the parentheses by the number and then add those products together. This property also applies to subtraction. So if we go back to this situation here, 10 groups of 4 girls and 5 boys, look down below here. I have 2 numbers inside the parentheses, and those are called addends because they're being added together. And according to the distributive property, I could actually, instead of adding 4 plus 5 and getting 9 and then multiplying it by 10, the distributive property says I can take the number 10, multiply it by 4, and I would get 10 times 4, which is 40, and I can add it to 10 times 5, which is 50. So essentially, I'm taking each addend inside and I'm multiplying it by the number on the outside, which is also represented right up here. It's actually a great way to multiply when you have numbers in parentheses, and I think you're really going to enjoy this property. So let's practice on our own for just a second. What might we do here? Well, let's look at this. 3 times 2 plus 4, according to the distributive property, is the same as figuring out 3 times 2 plus 3 times 4. And when we look back at the definition allows us to multiply this outside number 3 by each addend inside. Well, why don't we just check and prove this distributive property out ourselves? What would you do normally if you had 3 times 2 plus 4? Well, sometimes you learn with the order of operations that you do whatever in the parentheses. So 3 times 2 plus 4 is like saying 2 plus 4 is 6. And then 3 times 6 is 18. Well, the distributive property says I could take 3 times 2, which I'd get 6, plus 3 times 4, which is 12. And what is 6 plus 12? Well, look at that. It's also 18. So we just proved that we can rewrite certain situations using the distributive property, and we'll get the same answer, which is really going to help you, particularly in algebra. Okay, now let's do a question together that's a little more typically real world. Let's get back to those groups of boys and girls. If I have 24 boys in the class and 36 girls, what is the greatest number of groupings of boys and girls that I can make? And I want you to represent that using the distributive property. So what's the first thing we do? Well, the first thing we do is we find the GCF of 24 and 36, because this question is asking for the greatest number of groupings. And right when I hear that in a word problem, greatest number of groupings, I know I can use the greatest common factor. So why don't you press pause on this video, find the greatest common factor of 24 and 36, and then we'll guide you from there. Alrighty, so we listed all the factors of 24 and all the factors of 36, and I noticed that 12 is the GCF, which means that I could have 12 groupings of boys and girls and have the same amount of girls in each group and boys in each group. So now how do I find the amount of girls and boys in a group? Well, if I have 12 groups and there's 24 boys, I'm going to take those 24 boys and divide them into 12 groups. So essentially, I'm doing 24 divided by 12. So that would be 2 boys per group. And then, when I look at how many girls I have 36 girls. So 36 girls divided into 12 groupings would be 3 girls per group. How do I write this using the distributive property? Well, I could say that I have 12 groups times the amount of kids in each group. Well, the amount of kids in each group is broken into boys and girls. So there's 2 boys plus 3 girls. So I have 12 times 2 plus 3. And essentially, I could add 2 plus 3 and get 5. And then do 5 times 12, which is 60 children, which is true, because 24 plus 36 is 60. But I also could do it quicker, and I can say 12 times 2, follow my arrows please, 12 times 2 is 24, plus 12 times 3, which is 36. So I can say that 12 times 2 plus 3 is the same as saying 24 plus 36. And we can also work backwards. I can give you 24 plus 36, and you can find the greatest common factor, and we can go back and forth. But it would always equal to 60 students. There's just lots of ways to write out groupings. Alrighty, before we move on to practice our own, I want to show you the steps to using the distributive property. So step 1 would be to find the GCF. So for in this example, if I give you 45 plus 54, and in my head I can imagine a scenario, 45 girls and 54 boys. So if I want to rewrite that using the distributive property, I can use the greatest common factor because I can think of my groupings again. So the first step, find the GCF of 45 and 54. And after I do my factor rainbow or any strategy I've learned, I realize 9 is the greatest common factor. So I'm going to put 9 on the outside of my parentheses. It's going to be the greatest number of groupings would be 9. And then to find my add-ins, which is step 2, I'm going to use that GCF and distributive property to rewrite the sum. So I take my 45 and I divide it by 9, or I could say what times 9 gives me 45. And I know that 9 times 6 is 45. Sorry, 9 times 5 is 45. 9 times 5 is 45. And then 9 times 6 is 54. So essentially, the numbers that I'm going to be rewriting, the add-ins I'm trying to figure out, are 5 and 6. So I can rewrite 45 plus 54 as 9, which is the GCF, or the greatest common factor, or the greatest number of groupings I can make, which is 9. And then 5 plus 6 are the add-ins on the inside, because 9 times 5 is 45, and 9 times 6 is 54. So this is just another way of rewriting 45 plus 54. When you move on to your independent practice, you can remember these steps. They'll also be written for you on the page, and these were also your notes in class. But this is just another way to rewrite two numbers when I'm adding them together. It also works for subtraction, which we'll get to at a later point. So what we would like you to try are these three problems. So use the distributive property and rewrite 16 plus 56, 12 plus 8, and 26 plus 35. And over on your right, we've written some steps that should you forget, you can remember how to rewrite these problems. So, step 1, find the GCF of both numbers. Take that GCF, divide each add-in by that GCF, and then you're rewriting it. So, press pause on this video. Take some time to try these out yourself. And then when we come back, we're going to allow you to self-assess and see where you're at using the distributive property. Please make a note that there's a slight correction in question 3. It's not 26 plus 35. It's actually 28 plus 35. Some of you probably realize that you weren't able to find a greatest common factor of 26 plus 35. It was a misprint. So now try number 3, 28 plus 35. Alrighty, now we're ready to self-check. So look at the questions that you have written down and the work that you did. So for the first question, 16 plus 56, we have a greatest common factor of 4. And we took that greatest common factor and divided each add-in. So we did 16 divided by 4 and got 4, plus 56 divided by 4 and got 14. So I can rewrite 16 plus 56 as being equivalent to 4 times 4 plus 14. I can prove this to you by using the distributive property and saying, okay, 4 times 4. I'm distributing the number 4 across the add-ins. So 4 times 4 is 16. And this is an addition problem, so I'm adding 4 times 14. And 4 times 14 is 56. So as you can see, I rewrote 16 plus 56 into 4 groups of 4 plus 14, and then I went back and proved it to you that it is 16 plus 56 by using the distributive property. Same with 12 plus 8. We know the sum is 20, so we can actually check that in the end. I took 12 and I took 8, and I found the GCF, which was also 4. And I knew I could make 4 groups. And I took my 12, divided it by 4, and got 3. And then I took my 8 and divided it by 4 and got 2. So I know I can rewrite 12 plus 8 as being 4 times 3 plus 2. 3 plus 2 is 5. 5 times 4 is 20. So I know I'm correct in my rewriting of 12 plus 8. I'll prove to you using the distributive property that 12 plus 8 is 4 times 3 plus 2. And remember, this is something you can do when you're solving these problems. Always check your work. So when you're rewriting these sums using the distributive property, always check it. Is 4 times 3 plus 4 times 2 12 plus 8? Well, 4 times 3 is 12 plus 4 times 2, which is 8. So I know that I rewrote this addition problem correctly. And the last one is 28 plus 35. I can rewrite 28 plus 35 by finding the greatest common factor of 28 and 35, which is 7. I take that greatest common factor of 7 and I divide each add-in by 7. So 28 divided by 7 and 35 divided by 7. 28 divided by 7 is 4, and 35 divided by 7 is 5. So I can rewrite 28 plus 35 as 7 times 4 plus 5. The distributive property allows me to take this outside number, which is the GCF, and multiply it by each addend. So 7 times 4 is 28, and 7 times 5 is 35. So I can rewrite that as 28 plus 35, which is what I started with. So the distributive property is a really helpful property when I'm rewriting sums and using the greatest common factor. I know that if I wanted to check my work, I could use the distributive property. We hope this video, along with your classwork, has helped you explore the distributive property. Make sure to watch it over and over again when you're reviewing for your exams.